So for today, we'll be tackling the topic of integral calculus. So again, this will be a series of videos. So this will be a playlist of videos topic of most of the topics that most of the topics in integral calculus. So I hope that you will all watch the videos of covering this topic. So without further ado, let's get into it. So we have the first topic, which is the indefinite integral. Okay. So for the indefinite integral, so that is the integral without limit, and answer contains the c, or the constant of integration. So recalling, there are multiple ways to solve an indefinite integral. So this integral will have no limits. So we have the first one, which is the basic formulas, standard formulas, or the derived formulas, and method of integration, which are integration by parts, algebraic substitution, trigonometric substitution, and partial fraction. So I think there are more techniques that you can do, but this is most of the ways that you can solve the indefinite integral. So we have here the trigonometric substitution, where you can replace if you see something like this, okay? And this one and this one. Okay, so a squared, or a will be a constant most of the time, and u will be your the one that contains a variable, which is most of the time x. So let's get to the first problem. So we have the first problem, which is evaluate the integral of 4e raised to 3 ln x dx. Okay, so writing that down, you'll have something like this. So 4e 3 L, ln x dx. So if you will rewrite this, you can bring out the constant. You can always do that. So bringing that out, and then the 3 here can go here, right, to the power of the ln by an logarithmic property. So you'll have your ln x cube, okay, dx. And then with this, every time that e and ln are beside each other, you can cancel them out. So canceling them out, you'll be left with x cube dx. So now with this one, you can now easily integrate this using just the power rule. So power rule, you have here 4, and then the integral of x cube is x raised to 4 divided by 4. Okay, so this doesn't have any limit, so this must have plus c, and then simplifying that, the 4 will cancel, so you'll be left with x raised to 4 plus c. Okay, so that will be your answer. Okay, so we have for number 2, evaluate the integral of dx. This is actually dx over 4 plus 9x squared. So you'll have here something like this. So integral of dx, and then 4 plus 9x squared. So integrating that is just a inverse trigonometric function. So remember that formula is, if you have here integral of, okay, so if you have here integral of, the formula here is du over a squared plus u squared. This is just equal to 1 over a, okay, okay, and then arctan of u over a plus c. Okay, so from that equation, you can have that a squared here is 4, therefore you can say that a is just equal to 2, and then u squared is equal to 9x squared, therefore u is 3x. Okay, so just apply the formula. So applying the formula, you'll just have here is just equal to 1 over a, so that is 1/2, okay, arctan times u over a. Your u is 3x, and then your a is 2. Okay, and then plus c, and this will be your answer. So now we have number 3. So for number 3, evaluate the integral of x ln x dx. Okay. So what the technique that you will be using here is the integration by parts, or the IPP. Remember that for that one, the formula is integral of uv, uh, no, integral of u dv is equal to uv minus integral of v du. Okay, so one of the x and ln x, one of x, so you'll have your x and ln x, so one of that will be du and one of that will be the dv. So usually you'll have your u and dv is dv. So your u here is usually the one that is easy to derivative. So we have there ln x and x. So x is easy to take the integral of u, and x is easy to integral and then derivative. So it can either be the one. So ln x is kind of hard to integral. So let's make it our u. Okay, ln x. Therefore, we can easily say that our du will be 1 over x dx. And then our dv will be x. Therefore, we can easily say that the v is x squared. This is actually x dx. X dx. So this is x squared over 2. So applying the formula, therefore, you'll have your uv. So that is x squared over 2 times, that will be your v, and then your u is ln x, minus the integral of v du. So v is x dx. So we have your x, and then du is v du, right? No. V is x squared. Okay, so x squared over 2, and then du is times 1 over x dx. Okay, so this one is already, we can just simplify or write it down like this one. So x squared ln x over 2 all over 2 minus, simplifying this, you'll have, you can cancel out one of the x, and I can also bring out the 1/2 to make it easier. So this is just x dx. Okay, now you can make the integral. So again, this is just x squared ln x all over 2, and then minus, you'll have here 1/2, integral of x is just x squared over 2. Don't forget the plus. Okay, so maybe to make it simpler, you can have here 1/2 x squared ln x minus, so this will become 1/4 x squared, okay, plus c. Okay, so this will be your answer. So let's move on to the next topic.